Training an AI robot involves a combination of hardware setup, software development, and machine learning techniques. Below is an overview of the process. 1. Define the objective. Identify the task. Determine what you want the AI robot to accomplish, e.g., object recognition, navigation, speech recognition, manipulation tasks. Set performance metrics. Establish criteria to measure the success of the training, e.g., accuracy, speed, efficiency. 2. Choose the hardware sensors. Select appropriate sensors, cameras, LiDAR, microphones to gather data from the environment. Actuators. Equip the robot with actuators, motors, servos that allow it to move and interact with its surroundings. Computational power. Choose a processing unit, e.g., GPU, FPGA, edge computing device that can handle AI computations. 3. Collect data collection. Gather data relevant to the tasks you want the AI to learn. For example, if the task is object recognition, collect images or video data. Label data. Annotate the data with labels or categories, which will be used to train the model. 4. Select or develop the model. Pre-trained models. Start with a pre-trained model, e.g., a convolutional neural network for image recognition, and fine-tune it for your specific task. Custom models. Develop custom models if pre-trained ones are not suitable. This involves choosing the architecture, e.g., CNNs, RNNs, transformers, and initializing it. 5. Training the model supervised learning. Use labeled data to train the model by feeding it input data and correcting it based on the output. Reinforcement learning. Train the robot through trial and error, providing rewards or penalties based on its actions. Transfer learning. Use a pre-trained model on a related task and fine-tune it with your data. Simulation training. Train the AI in a simulated environment before deploying it in the real world. 6. Test and validate validation. Set. Use a separate set of data to validate the model's performance. Real-world testing. Test the robot in real-world scenarios to ensure it performs well outside of a controlled environment. 7. Deploy and monitor. Deploy the model. Install the trained model onto the robot's processing unit. Continuous learning. Allow the robot to continue learning from its environment, adapting to new situations over time. Monitoring. Regularly monitor the robot's performance and update the model if necessary. 8. Refinement feedback. Loop. Gather feedback on the robot's performance, retrain with additional data, or fine-tune the model as needed. Iterate. Continuously improve the system by iterating through the training and testing phases. 9. Ethical considerations. Bias mitigation. Ensure the training data is diverse and unbiased to prevent the robot from developing biased behavior. Safety protocols. Implement safety measures to prevent the robot from causing harm to people or the environment. Training an AI robot is an iterative process that involves careful planning, testing, and continuous improvement to ensure it functions as intended in real-world scenarios.